Right, I'm going to go through this engineering, maths and modelling question, so module CIVE1560 for June 2024, the exam in June 2024. And this is specifically a vectors question. It's got several elements that are typical in exam questions on vectors for this module, so you really need to be on top of everything that's in these types of questions that I'm showing you here. So one thing that this question says, before we get into it, it says use the geometric method only. What this question is about adding vectors. It says use the geometric question only. What we don't want is to use coordinates where you're resolving forces, etc. What you want to see in this question is a question that uses the law of sines or law of cosines. And we'll get onto those in a moment. So remember that. Geometric means law of sines or law of cosines in this exam. So the first thing we need to do is to draw a set of vectors to represent the forces. And we've got three lines on this diagram, A, B, C, D, B, C. And we know that the forces are in equilibrium, we're told that. So we can sketch, well, one force we know is this DB. We can then say, well, we know BC, we know the line of BC, the force is going to act along there, BC. And joining them will be something that represents the force AB. We can add on to that 80. I'm not going to put on the units there. 80 kilonewtons. We could sketch this in a slightly different way. We could say, well, we've got our 80. Let's draw AB along here, and we do a line up at the same angle. So let's just, there's a few ways of labelling this. I'm going to label this with the DB as the known, because that's the known, and we'll call this, I might call this A. So we've got AB along the top, and then this one represents BC. Now we've got the geometry. We're given the geometry, we're told it's 450 centimetres high. We know this length here is 400 centimetres. We know that this is 250 centimetres. Or if we're looking at this diagram, those two distances are the other way around, 400 centimetres and 250 centimetres. We're going to have to look at the angles in this. What I'm going to use is this one here. Okay, I'm going to reproduce that on the next page. Okay, so we have, let me remember how I had it, D, B, C, labelled 80. We can put some construction line in there. This was 400 centimetres. This distance is 250 centimetres. And the height, 450 centimetres. Now, what else do we know? So we know 80. We don't know these angles. I'm going to label those as alpha, beta, and the whole angle at the top there as gamma. Now we simply do trigonometry here. Tan alpha equals that height 450 over the adjacent 400, which leads to alpha equals 48.4 degrees. We can write similarly tan beta is 450 over 250, leads to beta equals 60.9 degrees. And you see I've only used one decimal place here, that's more than sufficient. Gamma, well, we know gamma is equal to 180 minus alpha minus beta, which leads to gamma equals 70.7 degrees. So we can apply either the sine rule or the cosine rule. And in this case it's going to be the sine rule, so let me just write the sine rule out here. Sine alpha over FBC on this, and I'll call that FBC, is equal to sine beta over 80, which is equal to sine gamma over, and I'll call this FAB because that's the label on the original diagram, FAB. And the unknowns we want to calculate here are these two forces. We've got the alpha, beta, gamma, and 80. So let's write it out as we have there. Sine alpha, which is 48.4 over FBC, is equal to sine beta 60.9 over 80, which leads to FBC equals 68.8 kilonewtons. We can also do sine of gamma 70.7 over FAB equals this same again, sine 60.9 over 80, which leads to FAB equals 86.4 kilonewtons. Those are the answers. The question, it says determine the tension in each segment of chain A, B and BC, considering the force in dB is 80. So those are the two answers. In other questions you may have to apply the cosine law, but in this question it was the sine law. Look at what is the missing information.